Hello guys, welcome to another discussion. So in this discussion, we are going to look at the product rule. So now before we begin the product rule, we are going to look at how and when do we use it, or when do we apply it, because we don't just use it. So when do we use it and when do we apply it? So if we are given a function y which is equals to f of x multiplied by g of x. Now understand to say that f of x, it is some function of x multiplying with the g of x, which is another function of x. So in other words, you are trying to say that given a function y which is equals to two functions of x multiplying like that, now how are we supposed to differentiate y? So we're going to use this method, or the product rule, where we say dy dx is equals to f times g prime plus g times f prime. Meaning that to find this, first of all, we are going to need to differentiate this and that, so that we get g prime of x and also f prime of x. So here's an example on the board. We have a function y which is equals to x squared plus 1 multiplying with the 2x minus x cubed plus 1. So you can see that there's this function and that function. These two functions are multiplying. So to find dy dx, or differentiating this function, first of all we need to get these two, where we are going to differentiate this and also that, so that we can use the formula. So for a start, we're going to say what is f prime of x. We need to find this one, f prime of x. These two, you can treat any of them as f of x and g of x. So for a start, we are going to take this one as f of x. So differentiating this one, we are going to remain with the 2x like that. And then we got for the second one, which is g prime of x. So g prime of x, this one is then our g, of which, differentiating this one, you're going to remain with 2 minus 3x squared like that. So we now have f prime of x and also g prime of x. And then this is f of x, g of x. So getting our dy dx will then be given by and then at this point, the only thing that we can do now is to substitute what we have for everywhere here. So we can say what is f of x? F of x is given by x squared plus 1. We close, but then g prime of x. G prime of x is 2 minus 3x squared, close. Then plus g of x. What is g of x? G of x is this function here, which is 2x minus x cubed plus 1, close, open, f prime of x, which is 2x like that. Alright then. So now the only thing that is remaining is actually multiplying through these, so that we have our simplified answer. So we can then say this times everything in there plus this times everything in there. Also this side, this times everything in here. So this is what you are going to do. So now at this stage, the only thing that is supposed to be done is actually grouping the like terms. How do we group the like terms? Those with same powers, they are going to be treated as one. So the solution, I'll bring it here so that we see. So now I'll group them to say those with the second power together. So we have 2x squared minus 3x squared plus 4x squared, like that. Then we also have the fourth power. So those with the fourth power, we have this one and that one, which is negative 3x power 4 minus 2x power 4. And then last we have a constant 2 here and the 2x. So we're going to write our 2x, I'll squeeze it here, 2x, and then plus the constant 2 down there, like that. This is due to space. So adding these together and those together, see what we get. Alright, now, so this becomes our final solution, or this is our dy dx of this function here. Can we look at another example based on the product rule? Okay, so here's another example based on the product rule. So how can we find, or how can we differentiate this function based on the product rule? So as we have already discussed, we say for the product rule, we need to have a function where we have two other functions multiplying together. Those functions, based on what we are working with, they could be the functions of x. So finding dy dx is given by this formula here, or this is what we use. So for this one, the first thing that we are going to do is, first of all, consider, we can see to say we have this function multiplying with that function. So we can treat one of them as f of x, the other one as g of x, so that f prime of x based on this one, we are going to get that. And then g prime of x. So g prime of x, we differentiate what we have here. So this gives us 6x squared plus 4, like that. Then from here, following that formula, we have that dy dx is equals to f of x times g prime of x plus g of x times f prime of x, like that. So now, what is our f of x? Our f of x is this one, which is there. What is our g prime of x? G prime of x is given here, which is 6x squared plus 4, we close, plus what is our g of x? G of x is this function, and then what is our f prime of x? So I'll start by writing the f prime of x, which is this here, f prime of x times g of x, which is given by this, right? So from here, the only thing that is what you're supposed to do is either you multiply this through with whatsoever is inside there, or you can simplify if that is possible. That is only if it's possible. So simplifying this one is as good as we have e to the power of x here and also e to the power of x there. So we can factor out this. So factoring this out, this leaves us with x squared plus 4. Then this plus here, we're going to say plus what we have this side, which is 2x cubed plus 4x, like that. So from here, I'll bring my solution up there so that everyone can see. Dy dx is equals to this. And then for what we have inside here, if there are no like terms, I think the best we can do is to arrange them in a proper order, maybe beginning with the highest power. So you can say 2x cubed, and then what follows is 6x squared. So you can say plus 6x squared plus 4x plus 4x plus the last thing that we have here, we have a 4 here, so you can write a 4 there. So you can either leave your final solution like that, or further still you can still factor out a 2, because there's a 2 there, 2 there, 2 there, so you can factor out a 2 so that your final solution looks something like this. So this is your dy dx of this function. So this is basically how you work around with the product rule. The product rule, we are only going to use it for functions that are multiplying like that. You have two functions of x multiplying. This is when you bring in the product rule.